diagram here for a closed system. Closed system means that wherever you start, you get back to the same pressure and volume, which means you're back to the same temperature as well, assuming you haven't lost any gas. These Q's with the arrows going in, that's the energy fed into the engine. That's the energy coming in. So those Q's represent QH. QH is the energy flowing into the system, the energy that is being used to do the work. So QH is simply 84 plus 30, so 114 joules. We want to figure out the work done, so the work out. We want to figure out QC, the energy basically lost, the energy that doesn't go into doing work. And then the thermal efficiency for this heat engine. So we know QH. We know that QH is equal to the work plus QC. Please keep in mind this equation is absolute values only. No negative signs in this equation, only positive values. So we know QH. We need to figure out both the work and QC. Once we have one, it'll be easy to find the other. Now, if you remember, we know that work on a gas is the negative integral of P dV. It's the integral of the pressure with respect to the volume. We have a graph of pressure versus volume. So on a graph, what does the integral represent? The area under the curve. Now for this equation, we only need the positive sign. So we won't need to worry about whether it's negative or not. So the area under the curve. The area under the curve is the area in this triangle. Area of a triangle is 1/2 base times height. So the base is 100 cubic centimeters. The height is 200 kilopascals. Units. To get joules, we need our pressure to be in pascals and our volume to be in cubic meters. To convert from cubic centimeters to cubic meters, you have to multiply by 10 to the negative 6. Because there's 100 centimeters in a meter, but you have to cube the 100 since we're going from centimeters cubed to meters cubed. Kilopascals, kilo is 10 to the 3. Oh, sorry, pascals. So the work ends up being 10 joules. Now technically it is negative 10 joules, meaning energy's leaving our engine, which should make sense. An engine is designed to do work on something else, to make something else move. But as far as this equation up here is concerned, we only use positive values. So we know QH is 114 joules, work is 10 joules, so QC must be 104 joules in order for those to add up. Questions so far? Efficiency. Efficiency is the ratio of the work over QH. So 10 joules over the 114 joules. The efficiency ends up being 0.088, which is 8.8%. You can write it either way. Generally, we tend to convert it to a percentage and talk about it in terms of a percentage. But that's fine as well. This particular engine is not very efficient.